You benchmark two coding agents. Agent A fails. Agent B passes. So Agent B is smarter, right? Not so fast. A lot of the time, those are the same model. One of them just ran out of budget mid-thought. This week, the UK's AI Security Institute put a number on it, and it should change how you read every agent benchmark you've ever seen.
Here's the hidden variable nobody talks about, the token budget. To keep evaluation costs sane, benchmarks quietly cap how many tokens an agent can spend before we call it a failure. That cap isn't a detail, it's a thumb on the scale.
So the Institute ran a clean experiment. Same models, same tasks. The only thing they changed was the budget knob. 1 million tokens, 10 million, in some cases 50. Everything else held fixed. Just how much room does the agent get to think?
The result on software engineering, SWE-Bench Pro and Terminal Bench, success jumped about 25% going from 1 million to 10 million tokens. Same model, same task, 25% more solved, purely because it was allowed to keep working.
Security tasks were even hungrier. Around 8% of them were solved only above 10 million tokens. Some needed 50 million. Below that line, they looked impossible. Above it, they were just hard. The capability was always there. The budget wasn't.
Because a long task isn't one inference. It's a loop. Read, act, observe, correct. Read, act, observe, correct. Cut the budget short and you amputate the correction step. The agent isn't wrong, it's interrupted, and interrupted looks identical to incapable on a scoreboard.
There's a cleaner way to think about it. The tokens an agent needs scale with how long a human expert would take. A 1-minute task is cheap. A 3-hour task needs room to wander, backtrack, and retry, exactly like a person would. Budget for the task, not out of habit.
And it compounds. The Institute found newer, stronger models benefit disproportionately from a bigger budget. The better the model, the more you leave on the table by starving it. Under-budget a frontier model, and you're paying for a race car to sit in traffic. So, what do you actually do? 3 things. Stop trusting single-budget leaderboards. A score at a 1 million cap is measuring patience, not intelligence. Budget by task horizon, and instrument your own agents. Log tokens to success, and you'll find a cliff, a budget below which success collapses. Fund above the cliff. One honest caveat. This is not crank it to 50 million and win. Tokens cost money and latency. The point isn't to max the budget. It's that budget is a dial you're currently ignoring, and the right setting is task dependent. Measure the cliff. Then fund just past it. This rewrites how you read any leaderboard. From now on, the first question isn't what scored highest. It's at what budget. A model that wins at a 1 million cap and a model that wins at 10 million are answering 2 different questions. If the budget isn't published, the ranking is close to meaningless.
And measure the right thing. Not cost per token, cost per resolved task. A cheap agent that fails, retries, and reward hacks a fake passing test can cost far more than an expensive one that gets it right the first time. Tokens are the input. Resolved tasks are the output. Price the output.
This also reframes the one big agent versus a swarm debate. More sub-agents means the budget gets split. Each one thinks less. Sometimes coordination wins. Sometimes you've just starved 5 agents instead of feeding 1. Don't assume more agents is more capability. It might be the same budget, cut into smaller pieces.
So here's your homework. Take one real task your agent fails. Run it at a 1 million token cap, then at 10 million. Plot success against budget. If you see a cliff, a point where it suddenly starts working, you just found the real bottleneck, and it was never the model's intelligence. So before you swap models, check the budget. Your agent might not be dumb, it might just be broke. If this reframed how you read a benchmark, that's the whole channel, the engineering under the hype. Next time, we give a coding agent a prove it mode. This is the agent loop.